Let's see, what have we been up to here for the past couple of weeks since we did one of these? Oh yeah, inequalities and equations. This is the stuff we're experts at though, so it's not going to be that big of a deal. So all right, little bit of distributing, and if some of you are experts and you go flying ahead, that's okay, because you'll see what's going on here anyway. Maybe you get an early start on your homework check. So here, again, distributing means we're multiplying. So 4 times 2 would be 8, okay. Okay, now, I got the parentheses gone. That's my first job. So now, my next job, get the 4x by itself. How? Minus the 8. I'm with you. And then I just got one step to go. I'm undoing the times 4 by dividing by 4. And I'm good to go. Again, the only thing I worry about sometimes with somebody on this is don't turn this into an equals all of a sudden. Okay? If there's an arrow there at the start of the question, you need to finish with 1. Now, the next one does have equals though. And I still am always going to work on doing any distributing first. I don't like the parentheses. They got to go first. And again, the parentheses just mean we distribute, which is multiplying, but only to what's in the parentheses. Okay, not to that 6W on the end. But now I have a different dilemma. I have W's in 2 spots, but, bless you, they're on the same side of the equals. So yeah, I can just put them together. So what's 4 and negative 6 get me? Thought I heard it. If I got $4 and I go spend 6, how far in the hole am I? 2. So I'm 2 in the hole. So negative 2W plus 8. Everything else is staying the same. And now it looks like what we're always doing. We're trying to get our W's by themselves. And again, I know it's tempting because you see that minus 2W there and you want a plus. Don't do it. I'm multiplying by a negative 2. So I've got to divide by negative 2. And I'm done. And yes, I know, some of these get to be quite a few steps. I hear you on that completely. But you're experts at this stuff because equations are the thing I think we're best at. So. Okay, number 3, if I could yell this out at you on a test, well, I guess I technically could, but we always want to isolate our term that's got our variable. Okay, so if there's anything outside the box that's sitting there, minus 6, we have to do that before we get rid of the fraction. Because if we don't, well, we're probably not going to do it right. Okay. So we got rid of that, we got down to a fraction. How do I undo a fraction? How do I undo divide by 3? Times it. And here's the only other place I get worried. This 3 just cancels the 3 here. It doesn't distribute to the x and the minus 5. So we multiply both sides by 3, not just the side with the fraction. And then my last step would be to plus the 5. And I'm ready and raring to go. And it just kind of keeps repeating that up in this section, that we're just going to keep working on if my m's, in this case, my variable, again, they're on the same side, so I don't do the opposite. 6 and 4 is 10. Then I look and I go, okay. I got a 14 and a minus 9, because again, even though combined like terms, doesn't mean we add every time. So 14 minus 9 is 5. And if you can survive that first part, now we're back to the same thing we seem to be on all of these. I got 2 steps to get my m alone. I'm going to undo my plus 5.
20%. Is she here?
And then my last step tends to usually be divide, and it will be here to divide by the 10. But you've got to watch, keep your variable and the arrow and all those things go in the same direction. You can't randomly move the m to the right or switch the arrow, because that changes the answer. Okay, so as long as I leave those things alone, we'll be all right. Now then we're going to notice, story problems. Now, we don't have to solve them though. That's kind of nice. So here's what I would do. I always like drawing pictures with things when I can, especially when I see things like, oh, rectangle. Okay, rectangle. The length of a rectangle is 2 times the width. Okay? Now, if my width is W, my width, oh, hardy, wow. If my width is W, okay, if the length is 2 times the width, how could I write that on my length side?
2x.
Yeah, 2x, 2w, whatever it happens to be. We'll just want to use the same variable. And then what else do I know about opposite sides of a rectangle? They're equal. So this is also 2w, and this is w. So if I want to make my equation, now what do we do when we're looking for the perimeter? What do we do with the sides? Add them. So I'm just going to take all the sides, so 2w and w and 2w and w, and set them equal to the perimeter. That's my equation. I'm done. I don't have to solve it. I don't need to combine like terms. I don't have to do nothing fancy like that. Just get it to the equation and you're good. They're like, oh, consecutive integers. Now here's the hardy plug for notes again. If you've got notes on this stuff, because we did that with the consecutive integers, you can use that tomorrow. That's kind of a cool thing. But when we're doing consecutive integers, remember, we kind of, let me go into this first. We were talking about numbers, like if I was doing 3 and 4 and 5, and how it would be, well, I'm adding 1, and then I'm adding 2, and if I went to 6, I was adding 3. So when I'm doing consecutive integers, my first number is x. My second number is x plus 1. So just like if this were 3, the next one would be 3 plus 1, which is 4. And if I kept going, there'd be x plus 2, and then x plus 3. So if it says 2 consecutive integers, there's my first one, plus, there's my second one, and then it says a sum of 18. Again, you're done. You don't have to solve it. You don't have to figure them out, and nothing fancy. It's just, we're just writing a little mini equation here. Now, there's one little tweak when we get to 7, though. Okay, if it's consecutive, I just keep adding 1 each time. Because if you're counting, you normally add 1. 3, 4, 5, 6, and so on. The next one changes a little. It says consecutive even integers. So let's see here for a minute. So like if I had 6 and 8 and 10, and I kept counting in evens, if this were my first number, I add 2 to it to get the next number. What do I add to 6 to get to 10? 4. So when I'm doing even or odd integers, it goes up by 2 each time. So if I want to do the first 3, so there's my first one. Then here's my second one. And then finally, here's my third one. I keep going up by 2 each time. And then they tell me what it equals. Again, you don't have to solve it. If it's just consecutive, I add 1 to each number they ask me. If it says even, or if it says odd, I'm going to add 2 each time. And if you need to write some numbers down, some evens or some just counting numbers to kind of get you thinking about it that way, that's okay. But I know we did this on the note sheet. Just saying. All right, more equationing. All right, write the equation to solve for x. Do not solve. This is real similar to the one we made up in number 5. Because we already said we know the opposite sides are equal. But this time, let's take it one step further. We'll simplify a little bit. We're not going to solve, though. So if I put together all the terms that are alike. How many total x's do I have? 6, because these are each ones. Okay. So let's see. 4 minus 3 is 1. 1 plus 4 is 5. Minus 3 is 2. And they tell me what the perimeter equals. Okay, again, don't have to solve it. Keep life simple. Now, when we get to number 9, we find, oh no, we even get to just do the equation again. This is great. Number 9. Now, you remember, I won't go run and jump and grab it out of the sheet again there, but when we had the note sheet, ooh, need to find that note sheet. The note sheet that had explanations of all these on it, because again, midpoint just means equals. So I just put an equals in the middle. Okay, equation only, that's it. Just learning how to set these up and make this work for me. Write the equation only to solve for x. Yeah, that's really kind of weirdly worded, isn't it? Need to word that differently. Let's see, just the equation only here. We will get a chance to solve, though, here as we get to the back. Here we go. Now we get to start doing some math. All right, find the missing segments, show all work. Notice it doesn't say midpoint anywhere, so those are not equal to each other. But I know that if I add this part and this other part together, I get the whole thing. So what I'm going to do is I'm going to add those two parts up, and they equal the whole. So we've done this before. If we're adding them up, we're going to combine like terms. So 3x and another 1x is 4x. Let's see. Ooh, I got $1 and I went and spent 10. Eee. How far in the hole am I going to be? It's 10 minus 1. Yeah. $9 in the hole. But this one we're actually going to solve. So just like we've been doing, you're like, Hardy, I swear we're doing the same thing on every problem. We are to a point. There's a lot of flexibility with equations. I'm going to undo my minus 9. I'm going to plus 9. And then my last step always seems to be we're going to divide. Okay, but again, I'm not quite done. It wants me to find what MJ is, which is this part. So if MJ's equation is x minus 10, what? That wasn't well set up. Oh well. So you're like, wait a minute, that'd be 9 minus 10. That'd be -1. Normally that would be cause for concern, but I think what Mr. Hardy did was he'd flipped signs on what he was going to do. So we did everything right. I did an oops. It's me. Because normally we don't get segments that are negative numbers. That doesn't make sense. But if I plug 9 in there, it's 20. Yeah. It's Mr. Hardy on that one. All right. What equation would you use to solve for x in the triangle? How many degrees are there in a triangle? 180. So if there's 180 in the triangle and I have 3 angles, I would add up those 3 parts and set them equal to 180. Now I'm not going to solve it because it says what equation, but I am going to simplify it a little more. Let's see here, 54 and 89. How good's my brain working this morning? 130, 140. Yeah, we don't have to solve. It just says what equation would you use? And that's what we'd do. So we'd add up the angles, and then I'd have to solve for the x. Now, I wouldn't mark it wrong if you did solve. It's just more work than you'd have to do for that one necessarily. All right, let's see what else we got working here. Find the missing angles, show all the work. Okay, when we have a straight angle, that's 180 degrees. When we have a right angle with the little square, that's 90. In both cases, the two angles make up the bigger angle. They equal the bigger angle. So on both of these, I'm going to combine like terms and set them equal to the whole angle. So I'll combine my x's. So 3x and 1x is 4x. Combine my number part. 2 and 2 is 4. Set that equal to 180. Because again, they didn't give me a value, or assuming I know that a straight angle is 180. And I got a note sheet to help me with that if I need it. And then again, you're like, okay, two-step equation again, Hardy. I know, this is why I say, if you can do two-step equations, basically you're going to be good when it comes to this stuff. And if not, we just got to work on it a little more. I think that goes in evenly. 44, I believe. And then again, don't be content with just getting x. It says I want to know what ABC is. Okay, ABC is 3x plus 2. So I just plug in the 44 where the x is, because I know what x is now. I know its value. And I just pop this up in the calculator. Let's see. 132 plus 2. And I get my angle. So it's basically just straight up substitution. Two-step equations and substitutions, all we're looking for here. And it'll be the exact same idea as we're doing number 13. Again, find your like terms, put those together. Do the same thing with your numbers. And this time, though, it's just the right angle. It's my little square. So I'm going to set it equal to 90. Again, we're working on isolating x. So we want to undo the plus 5. So we're going to minus 5, do its opposite. And it always seems that last step is to divide. So we get that set. And then again, I got to be careful. CBD. Okay, so this one. Okay, so this angle is this. So we've got 2x plus 4. But I know what x is. It's 17. So 2 times 17 is 34. Plus 4 is 38. And I'm a happy camper. But you do have to know a little bit here to know, am I setting them equal? Am I adding them to each other? What are they equal? That's what that note sheet's there to help you with. And again, if you don't have one, I think there might be a few over in the folder still. I know they're online, so you might be able to find them with somebody there. And then finally, what we've been doing lately. Okay, use multiplication and division of rates to complete. And they give me some information up here, so don't come down here and go, well, I don't know. Just look up here if you need it. So at the fair, the octopus ride does 150 rotations per minute. Okay, they gave us that. How many times would you expect to spin per second? Well, I'm like, okay, my minutes canceled. So let's see here. So I'd have 150 rotations. But it's saying per second, per 1 second. So what you're really being asked to do is to take the fraction they gave you, 150 divided by 60, which means it would be 2.5 rotations per second. Man, that's going kind of fast. So when it says per second, it means we're just getting down to 1. In other words, just divide this and whatever answer you get is going to go up here. But we're always going to give you the information that you need to be able to do this. So we talked about canceling before, and I should have an R with it. I'm like, okay, I want hours. Ooh, I don't want days. I want weeks. So if I want the days to cancel, I'm going to have days up here, because then they'll cancel. I got weeks down here. Well, what's the relationship here? How many days are in a week? 7. So then I look, I'm like, oh, the days cancel. 24 times 7 is 168. I got hours. Days cancel. 1 times 1 week. Oh, okay, just wanted this part. All right. And I can figure out the part in the middle. Again, not bad. Now, don't panic on the last one. Because you're going to look at the last one, you're going to be like, oh my gosh, how am I supposed to get all this to work? Keep what you've got up here in mind. You're going to be able to see it on your paper. You won't be able to see it on mine here at the start, but you've got yours. So I'm at money, I'm at dollars per yard, and I want to get to cents and inches. Well, if I want to get to cents and inches, I need to eliminate dollars. So if $1, it says, is 100 cents. Okay, so then I can get rid of the dollars. Then I don't want yards, I want inches. So I'd have to put yards up here and inches down here. But again, up at the top it tells me that 1 yard is 36 inches. So by doing that, now I can cancel out the yards because one's in the top and one's in the bottom. And notice the labels that are left. I got cents up top, inches down below. So let's multiply this out and see what we end up with. So I got 5.60 times 100. All right, so that's 560. Down here, everything's canceled but the 36. But again, we want to know per inch. So sort of like what we did up in number 14, I'm just going to divide the numbers I have now. 560 divided by 36. Round to the nearest penny. So we'll round up. So 15.55 would be 16 cents per inch. And that's how they figure these things out. If you go into a store, you're buying something by the yard, by the pound, by the ounce, by the whatever it happens to be, the gallon. That's how this all gets figured out. They take the large quantities and figure out what they're going to be like small. So, okay. Tomorrow, this test that you're getting, you'll never guess how many questions it is. 16. Okay? It's going to set up just like this. No different. I'm going to have this online. If you get stuck on something, you want to double check in the morning, I'll be here in the morning. I'll be here after today. All that stuff. I want you to spend the rest of the time today working on the homework check. Now,